Chapter 31, Dosage Calculations based on BSA, which is your body surface area. Learning objectives. Of course, after completing this chapter, the student will be able to identify which types of drugs are dosed according to body surface area. Use a nomogram to calculate your body surface area. Perform dosing calculations for drugs based on body surface area. So your BSA, which is your body surface area, is used accurately to calculate doses for patients receiving chemotherapy agents. BSA, of course, is expressed as square meters. Body surface area is calculated using patient body weight and height, and of course can be determined by referring to a standard nomogram. So a nomogram has three columns. It has the height, which can be expressed either in centimeters or in inches, body surface area, which is going to be expressed in square meters, and weight, which could be expressed in either kilograms or in pounds. So the height and weight of the patient are found on the nomogram, and then a straight line is drawn connecting the two values. The BSA for that patient is found where the line intersects the BSA column. Many manufacturers of chemotherapy drugs supply BSA calculators with sliding scales. The principle of finding the BSA is similar to the nomogram. Now, more than likely on your um, certification test that you do at the end of the year, they are going to give you the BSA. You won't have to find it. Okay. But this is just showing you how to find it if you don't know what it is already. Excuse me. So make sure, for the class to use a straight edge, such as a ruler when measuring, or using a nomogram to calculate the BSA, just to make sure that you align it correctly. So on page 261 in your book, you have, of course, it shows you a picture, of course, of that nomogram. So you should, for these calculations for this class, you should use this one on page 261. Okay, first what we'll do is we'll go over to page 263, and we're going to run through a few of the practice exercises. Number 1, a physician orders a bolus dose of a drug for a patient with a BSA of 0.96 millimeters square, or meters square, excuse me. The drug dose is 75 milligrams per meter square. What is the bolus dose in milligram? So what you want to do is, you know that it comes in 75 milligrams per 1 meter square. And of course the BSA, it already tells you what the BSA is. It's put that on the bottom, 0.96 meters squared. When you're trying to find X milligram. So again, you're just going to do your ratio proportion. That's the reason why I teach ratio proportion, because you could do it with a lot of the formulas in pharmacy. You just have a few differences between the formulas. X times 1 is going to be 1, so on the bottom, 1x. 75 times 0.96 should be 72. Then it's 72 milligram for a patient of a 0.96 meter square BSA. Number 2, on this one we're going to have to find the patient's BSA. So a patient weighs 98 pounds and is 5 foot 1 inches tall. So you actually use both those numbers. So to find the BSA, you look on your scale, it says 98 pounds. And of course if you look on page 261, she's 98 pounds. So you go to the weight to where it says 98 pounds. And then pull the ruler over, of course, and it tells you what the BSA is. And then, of course, you have the one for the 5 foot 1 inches tall. Okay, so then what you're going to do is you're going to add those two together. Those BS2 added, it's like 1.82 plus 1.15. It comes out to be like 2.97. And then you're going to get the average of those two numbers to figure the BSA. So you divide it by 2, and it's 1.485. Okay, so So this would be the BSA, and again, it's always a meter square. So you know you have 10 milligrams per 1 meter square. You're trying to find X milligrams, and then you have 1.485 meters square. You're going to cross multiply. X times 1 is 1x. 10 times 1.485, you get 14.85. And what they do is they round that around to 15 milligrams. Okay, number 3 is telling you the BSA is 1.95 meters square and is ordered a dose of a drug of 40 milligrams per meter square 2 times daily. So just remember the 2 times daily. So what will be the daily dose in milligrams for this patient? Okay, so we know that the patient's BSA is 1.95 meters square over X milligrams. You have 1 meter square per 40 milligrams of the medicine. So again, our units are the same on top and bottom, so you're going to cross multiply. So X times 1X, 1.95 times 40 should be 78 milligrams. But then you want the daily dose, and it's 2 times a day. So you just hit time, multiply it by 2, and you come up with 156 milligrams. Okay, number 5. You have a patient's weight is 70 kilograms and height is 155 centimeters. Calculate the dose of the medicine, of course, in milligrams for the patient if the oncologist orders 400 milligrams per meter squared daily. So you look on your chart and her weight 70 kilograms. It's 1.62 meters square, about an average. 155 centimeters is going to be 1.83 meters square, and sometimes they round those. Remember, to get her BSA, you're going to add those and then divide it by 2. Okay. So now, of course, you know, of course, that the medication or the order comes in 400 milligrams per 1 meter square. And of course, it's you're trying to find X milligrams. And the patient's BSA, we just figured that out, is 1.73 meters square. Cross multiply, 1 times X goes on the bottom, be 1X. 400 times 1.73 is 692. So your answer is 692 milligrams. Okay, on number 6, we're going to find the milligrams first and then the milliliters. Kind of very similar to what we did in chapter 30. Okay, so number 6, a patient has a BSA of 1.54 meters square. The physician orders a daily dose of 900 milligrams per meter square of the drug methotrexate for this patient. What is the daily dose in milliliters if the concentration of methotrexate available is 25 milligrams per milliliter? Okay, so of course we know that the patient's BSA is 1.54 meters square, and we're going to find the milligrams first. Okay. And then of course the daily order dose is 900 milligrams per meter square. Oops. So be sure to line everything up. Even I have to go back and double check myself here. So make sure you put the milligrams on the bottom, 900 milligrams per 1 meter square. So our units are the same on top and bottom. 1 times X would be 1X, goes on the bottom. 1.54 times 900, you get 1,386. So you get 1,386 milligrams. So now we're trying to find milliliters. So you have 1,386 milligrams. We're trying to find X milliliters. Okay. It's available in 25 milligrams per 1 milliliter. Okay. Cross multiply, 25 times x goes on the bottom. I always put a little x with it, so I remember that it always goes on the bottom. 1,386 times 1 is 1,386. Divide that by 25, and you get 55.44 milliliters, which you can round to 55. Number 7. On page 264, a physician order is for andriamycin 25 milligrams per meter squared daily for 4 days. Remember, this is for 4 days. The patient has a 2.5 meter square BSA. What is the total amount in milligrams that the patient will receive over the 4 days? So you have 2.5 meters square. That's their BSA. Trying to find milligrams. And of course, it is order is for 25 milligrams per meter square. Make sure your units are the same on top and bottom. Cross multiply. 1 times x always goes on the bottom. 1x. 2.5 times 25 is 62.5. So it's 62.5 milligrams, or milligrams. But it's for 4 times a day, so you're going to multiply that by 4. And it comes out to be 250 milligrams for the daily dose. Okay, number 10. We have a drug, of course, that is ordered at 55 milligrams per meter square over 1 hour. The patient has a BSA of 1.93 meters square. The drug is going to be available as a concentration of 20 milligrams per milliliters. Calculate how many milliliters are needed for this patient's dose. So first, of course, we know that it comes at 55 milligrams per 1 meter square. And patient's BSA is 1.93 meters square. Try to find X milligram. Units are same on top and same on the bottom. Cross multiply. 1x goes on the bottom. 55 times 1.93. You get 106.15 milligrams. So that's divided by 1. It's going to remain the same. Okay, then if you read that the concentration is going to be available as 20 milligrams per 1 milliliter. Okay, so now we're trying to find the milliliters. So then you have your answer up here. So it's 106.15 milligrams. We're trying to find X milliliters. So cross multiply. 20 times X will go on the bottom. 106.15 times 1 is 106.15. Divide that by 20. You get 5.3 milliliters. Okay, so next we'll do number 12. A patient with a BSA of 1.52 meters square is ordered. The drug, of course, is 100 milligrams per meter square IV in 100 milliliters of 0.9% sodium chloride solution over 1 hour. Your medicine is going to be supplied as 200 milligrams of dry powder that is reconstituted to 10 milligrams per milliliters. Calculate how many milliliters are going to be added to the IV bag. Okay, so they're giving you some information there you don't need. But what you want to find the milligrams first and then the milliliters. Okay, so first you're going to do the BSA of the patient. So it's 1.52 meters square. Trying to find X milligrams. Okay, and then of course the ordered. So you're always going to do it the ordered first. It's 100 milligrams per 1 meter square. Cross multiply, 1x goes on the bottom, 1.52 times 100 will be 152. So you have 152 milligrams. Okay, so now we're going to take, and with the medicine comes in, or how it's reconstituted, this will be 10 milligrams per 1 milliliter. Your milligrams based on the patient's BSA is 152 milligrams. Do it over X milliliters. Cross multiply, because our units are all the same. X times 10, 10x goes on the bottom. 152 times 1 is 152. You're going to divide that by 10, and it comes out to 15.2 milliliters. Okay, we'll do one more. Number 16. So a patient with a BSA of 1.52 meters square is to receive a medicine or drug of 100 milligrams per meter square by a syringe pump over 2 hours. It is supplied as 525 milligrams per 25 milliliter vials. How many milliliters will be needed for this patient? Say the patient's BSA is 1.52 meters square, trying to find X milligrams. Okay, the drug ordered to be received is 100 milligrams per 1 meter square. Units are the same on top and the bottom. Cross multiply. 1x goes on the bottom. 1.52 times 100 would be 152 milligrams because it's divided by 1. The 152, the milligrams based on the patient's BSA is 152 milligrams. Now we got to find the milliliters amount to that. Okay. It is a supplied, or it comes in 525 milligrams per 25 milliliters. Okay. Then you just cross multiply. 525 divided by x always goes on the bottom. 152 times 25 is 3,800 divided by 525, and you get 7.23 milliliters, and you could round that down to 7.2 milliliters. Okay, so you can work a few of these problems in here, or do the ones I've done and then go back and check your answers with this video, whichever is easiest for you to do. If you have any questions or concerns, please send me an email.